Let's get started with part 3 of Lab 1, which has to do with Cartesian coordinates. And if you remember, Cartesian coordinates are x and y coordinates. They're perpendicular to each other. They have something called an origin, which is where both the x and y value are equal to 0, which would be right in the center here. X increases to the right, it goes negative to the left. Y increases upward and goes negative below that. In this case, each one of these boxes, these grid cells that we see, is 1 mile by 1 mile. So if you walk to here, it would be 1 mile of walking. If you walked downward from there to here, it would be another mile of walking, even though it's a negative number. And if you wanted to find the shortest distance, you would use the diagonal line here. So the first thing that you're going to do is you're going to plot some points. And some of these points are going to be along a river, and we'll do those first. So the first point along a river is at 5, 5. So I'm going to go ahead and create a point here. I'm going to put it in at 5, 1, 2, 3, 4, 5, x equals 5, y equals 5. It's going to go right up here. That's our first point. The next one is at 4, 3. So I'm going to copy and paste that point and put it 4 over in the x direction and 3 over in the y direction. And I'll put on one more point here at 2, 1. So there's going to be another point, 2 over in the x direction and 1 up in the y direction. So these are points along the river, and of course a river is continuous between these points, but we're just capturing certain points while we're walking around the field. So now let's put on what the values are, which point ID here relates to which one on the map, so that I'll know you've done that right. So for this, you'll use a text box. You'll type on a 1 for this one, a 2 for this one, and a 3 for this one. The next thing it asks you to do is connect all your points, and you're going to have more than 3 points. You're actually going to have 7 points along this river, but just to show the first 3, now you're going to put on a line that connects those. And we'll just use a straight line segment here. It goes from here. The first one goes from there to there, and this, make that blue and a little thicker. Show where it is. And the second one goes from here to there. Make that the same blue. Can't remember how thick it was. That looks about the same. So you're going to connect up all those points like that. The other thing that you're going to put on your map is where the mountain peaks are. And the mountain peaks are over here. They're not numbers, they're letters. Okay, so let's put 2 of these on A and B. So the first mountain peak is at x equals 5, y equals minus 5. And these we're going to put on as triangles just to make them something different. A little triangle there. And I'm going to make it brown to make it look more like a mountain. Brownish red. Okay, so first one was at x equals 5, y equals minus 5. It was down here. And let's put on one more. B is 2 and minus 2. So make a copy of that. And we're going to put this at 1, 2 and minus 2. Okay? And we don't have to connect those because those are 2 separate mountain peaks, but we will label them. The first one was peak A and the second one was peak B. So I'm going to go ahead and label those. Here's peak A. Here's peak B. And of course you'll be putting on 2 more mountain peaks here. Now, one of the things you have to do at various times in this is figure out what the straight line distance is between 2 points. So how far are the mountain peaks A and B apart? Let's do that one just because we already have those 2 points on. So what we want to use for this is the Pythagorean theorem. And what that says is that if we take the distance in the x direction and square it, plus the distance in the y direction and square it, and then that's going to equal the distance we would travel if we just went straight between those 2 points. So in this case, if we're going from A to B, we would be going 3 in the x direction and then 3 in the y direction. So that would be 3 squared plus 3 squared. So that would be 9 plus 9. And let me pull up a calculator here. So in the x direction, it's 3, and the y direction is also 3. That equals 18. And then if we take the square root of 18, this is the scientific calculator here, and if you look for this thing that looks like an X with a little house over it, and a 2, that means we're taking the square root of that. If we take the square root of 18, that gives us 4.2. So the distance between A and B would be 4.2, and you would report that over here. Okay, and you also have to find some other distances there. You also have to judge where the shortest distance is. So for example, if this point 2 were over here, that would be a shorter distance than if it were over here, because we're going down a straight line instead of crossing diagonally across 2 boxes here. So in this case here, that would be a shorter distance. Sometimes you can just estimate it. Other times you might have to use the Pythagorean theorem and do your x squared plus y squared and then take the square root of it. But you will have to report on some distances and judge some distances from this map in order to finish this exercise.